All right, little video about the E1 mechanism. Now, the reactants for the E1 mechanism are the exact same as for an SN2 mechanism in that it's preferred by tertiary alkyl halides. Now, the real requirement for an E1 mechanism is that one of the carbons next to the carbon that has the leaving group on it needs a hydrogen because that hydrogen is going to be removed in the elimination. If you're in the IB program, the hint that they want you to do an E1 mechanism is going to be the word ethanolic. Put it another way, they're going to say you use ethanol as the solvent as opposed to water. If they say ethanolic, they want an elimination. Cool? For the rest of you, if you're not in the IB program, the E1 and SN1 happen at the same time, and depending on the strength of the nucleophile, the solvent, the molecule you start with, it could be either, and probably a mixture of the two. Cool? Let's see how this works anyways. In the E1 mechanism, because you're starting with a tertiary alkyl halide, or rather the carbon that has the leaving group on it is connected to three other carbons, this iodine has a propensity to simply fall right off. A tertiary carbocation, which is what we're going to create here, is stable, which makes that I, or whatever leaving group is there, more likely to come off than if it wasn't there. I'm going to put a plus in its place here because the iodine is fully detached by the time I get here. This carbocation is our intermediate. It's relatively stable because it's a tertiary carbocation, and it is ripe to have a nucleophile. In this case, I'm going to use OH minus. Attack the hydrogen on the adjacent carbon. Now, when this, well, in this case, the hydroxide ion attacks that hydrogen, it will attach using one of its lone pairs. The electron pair that connects the carbon and hydrogen currently will flow this way into a pi bond because it is attracted to the positive charge of the carbocation. What this leaves us with is these two carbons now double bonded to each other. Attached to this carbon, we still have an H, and we still have this CH3. And on this carbon, I still have both my CH3 groups. In the end, what I've done is I've removed this I and this H. The I took this electron pair with it, and this electron pair flowed into the pi bond. Don't put the pink on your mechanism. I'm just reminding you where this stuff came from. And in the end, we have this free iodide, and we also have water, which is the OH that I chose to use as my nucleophile with the proton that it stole. Cool? Check it out. This is your mechanism. In an E1 mechanism, you have a unimolecular decomposition as your first step. The I is simply falling off. In fact, that is the slowest step of the mechanism and is the reason we have this first highest hump in the potential energy curve. By the time you get to this trough, you're at the intermediate. It's stable because tertiary carbocations are stable and ripe for attack by a nucleophile. The attack by the nucleophile is the second step. It's slightly faster than the first step. It's actually a bimolecular collision, but we don't really care. All we really care about is that we end up with an alkene in the end, because after all, it is an elimination. Now you can pause the video at the end and take a look at all these details that your teacher may want you to include in the mechanism. Some teachers are more forgiving. These are all the ones that the IB program requires. And I just want to remind you, this is an E1 because it is a unimolecular first step. The first step is only dependent on the the rate law only has the alkyl halide concentration in it. The OH minus concentration does not play a role in the rate because OH minus is not part of the rate determining step. It's part of the second faster step. Cool? Cool. That's the E1 mechanism. The only other thing I want to point out here is that I've been careful to make sure that the H that I remove and the I that falls off, or the leaving group that falls off, are on opposite sides of the molecule. In university chemistry, you'll need to remember that that's the case. It's called I think it's called an anti-conformation, where the H gets removed and the I gets removed at the same time. It's much less important in an E1 than it is in an E2. In fact, now that I think about it, I don't know if that even applies in E1, but nonetheless, I'm going to tell you anyways. I like showing the H and the I opposite each other, and then you make your alkene and you're done. Cool? Hopefully that last minute didn't waste the last minute of your life. But there's your E1 mechanism. Enjoy life. And if you have any questions, comment. Best of luck.